Hello. I made it. I'm a little bit late. I've been doing bits today, but we're back. It's good to see you all. Hope you've been having a good week. I've been a little bit busy these past couple of days, sorting out just various bits of admin shenanigans and things, which have kind of gotten in the way a little bit of doing the streams in the evening, but all good things. Very exciting things for me, very exciting for the studio, and very exciting for this little project as well, which I'm really loving how it's all coming together. And I'm going to spend a little bit of time talking about what I've been doing with the art style side of things, because I've spent the past couple of days probably just working on this shader, which you can't see behind my face. But I'll tell you what, actually, let me just pull this. Can I pull this up? Yeah, there we go. Over here on the right hand side, this is our custom painterly shader, and it looks so good. If I do say so myself, I'm genuinely so happy with how this has come out. And in the game scene as well, if I hit play here, we can take a look at what we've got going on. I'll talk a little bit about some other stuff as well, but yeah, here's the actual look of the game now. Still need to sort out colors, but we've got like full specular in this shader. The shadows are all supporting this paint texture. Let's bring the bucket over here as well, spawn some water in. Like, the water looks especially jiggly now when you're holding it. It actually looks like it's flowing around the place, and yeah, I'm so happy with how everything's looking at the moment. It's really, yeah, I'm well chuffed. Thank you so much. I'm very happy with it. We're going to do some more work on it today, actually, because there's a couple of issues which I'll talk about in a second, when I start talking about how I've actually made the shader. And we're going to make some changes so that we can do more things in shader graph rather than in HLSL, because at the moment, like, the whole thing is happening in HLSL, and the shader itself, I mean, I say that it looks not actually like there's that much going on, but this painterly lighting thing is doing most of the heavy lifting. The rest is just kind of plugging in textures and then like grabbing the color that I want, and then all this stuff going on up the top here is displacement things. But all of this lighting calculation with the paint texture and everything is all happening inside a HLSL custom node script. So we're going to have a look at that, break it down, try and split some things out so that we can control like the specular color, the normal color, and the lighting data separately in this, because then we should get a little bit more control over how we can have this ending up looking. Iron Bites, hello. Yeah, I'm not I'm not nearly done. I am quite far away still, I think. But you know, we're probably 2 weeks in. Just over 2 weeks in, maybe nearly 3 weeks. So I've got, you know, maybe 10 days. Oh dear, 10 days to try and get this game finished. But that's cool. We're going to do, hopefully today, I've got a lot planned for today, so I need to stop waffling like I usually do when I start these streams off. We are going to, like I say, work on this shader to try and give us some more control over things in the shader graph side of things, rather than having to do it all in HLSL. Oh my gosh, that's hard to say. We are going to refactor all of our placement stuff to work with the grid again, because for anyone who was here since the first stream, we originally had a grid component set up which was handling all of our placement. I want to go back to that again because I think it will give me some more flexibility around how players can play stuff, and it also means that I can relatively straightforwardly build like a shelf, because I'd really like players to be able to put their plant pots on shelves to display their things and stuff like that. Maybe we can make different shelves that have like extra features in them for watering plants automatically or cross-pollination, things like that. So those are kind of my two goals for the day, and yeah, they're both going to be kind of big. Ori Jack, what kind of game do I want to create? I am working at the moment on this cozy game with this nice paint texture about growing plants in your own little flower shop. It's probably best compared to Garden Galaxy, I would say. I think they will actually end up being quite similar in terms of general feel. The edge or the difference, I guess, in my game is the art style, first of all, with this in my opinion, nice looking paint finish, so everything looks like it's a stop frame animation, but then also the focus on the plants themselves and the ability to kind of cross-pollinate them and grow your own unique plants based on how you decide to do that. And then, yeah, giving the player all freedom to be zen and create what they want to do, blah, blah, blah. So, let's talk about this shader. Things are going to look different in the code as well. I've moved over exclusively to using VS Code for all my work now, because they're discontinuing support for Visual Studio on Mac. And I'm not going to switch away from Mac anytime soon, which people might hate me for, but I am well baked into the ecosystem because of all of my music production stuff that I do as well, and I enjoy the workflow. It does well for me with the M1 Mac, so I'm chilling, and Visual Studio Code is what I use for all my web development stuff as well anyway, so it's good times. Have I considered publishing the shader on the asset store? I've thought about it. I honestly have thought about it. If I could make it more robust, which hopefully we can do here, then, you know, maybe we can look, maybe I will look at doing that. Or more likely, I'll probably release it as a Patreon exclusive, because, you know, along with things like the Shiba utils classes that I've written, which have things like the save systems, UI management, scene management, like loads of stuff in there that I always bring in when I bootstrap a new Unity project. So much of my like boilerplate things, singletons, databases, like everything is in this folder, and that's going to be something that I want to put on Patreon rather than releasing as an asset, because I'd much rather like people who want to support the studio and enjoy, you know, the content that I make get something back from me as well if they want to support even more. So that's probably more likely what I'll do with it. That said, here's how I made it, because, you know, I'm not gonna keep any secrets. So first of all, I've got a struct here which has like all of the parameters that we need for actually setting this stuff up. We've got the color that we want the specular to be, some parameters for the normal angle of the surface of the object and the viewing angle, i.e. how the camera is looking at the object. There's then a half parameter which keeps track of the stroke map, so the texture that I want to use effectively for the strokes. It's just a value between 0 and 1 mapped on a, you know, a 2D coordinate. And then again, one for the stroke smoothness, which controls how we blend between, you know, if we've got some area that's within the threshold of light and dark, the smoothness controls like how it will ease between those values. And then the smoothness is for the specular property. The smoother the object, the more clear the specular is going to be. And the shadow intensity is actually how much shading we want to apply to something. So if I just pop over here real quick, I wonder, can I pop this out into its own screen? I don't think I can. I can. Amazing. There we go. So if we pop this out here, I'll make it nice and big so you guys can see what's going on. We've got... Hold on. Bang. There we go. So yeah, we can change what am I looking for? The shade intensity. If I'm at 0, we've got no shading in the shadows going on at all. And if we go all the way up to 1, it's like pure black in the darkness. So we can have some good control there over how it affects. And then again, with the stroke smoothness, you know, if we're at 0, it's just hard cut off. There's no blending. As we bring that up, we start to get some more smoothness in the paint texture to the point where it's almost like just raw texture. So that's quite cool. Surface smoothness, it's kind of hard to see at the moment because the color of the specular is being multiplied by the albedo color of the object, which is why we're going to try and move this out to doing more in shader graph rather than just the shader, because I would like that to be separate. But if we're, you know, all the way down at 0, not smooth at all, we get no reflection. If we're all the way up at 1, we get a really sharp reflection, which I don't know if you'll be able to see on the stream. There's like little flecks coming up there. At the moment, I kind of have to sit it around like 0.8 if I want to get anything to show through. So we're going to fix that. And we can change the color of that as well, make it red, you know, maybe you want purple reflections specifically. Like, this is nice ways of adding some extra color. There's something for adding variation to the base shade. So that literally just puts noise over the top of the texture. But you can have it quite low and it gives it just a little bit of extra depth. Shade variation scale, that's like how big the noise is. You know, we scale that up, you get lots of little noise. Bring that down, you get nothing. So it's just like a nice way of keeping it subtle. And I use that for the displacement as well, which we can adjust with this displacement strength. And that just distorts the vertex position in world space along the x-axis, but only the x-axis. To be fair, should probably also have it do the y-axis, but I didn't want it to do all three. Just felt like it looked a little nicer. And we do also have a thing for mapping like an albedo texture over the object. Like if I wanted to put on some tile, that is there. It's not plugged in at the moment. So I actually probably we need to look at plugging that in. It's a simple case of just taking this base albedo that we've got here and multiplying it with the texture. So maybe we do that first, actually. Am I a game dev? Yes, I like to think I am, or I would say I am. I make games. I don't make a full-time salary from it. I'm not employed. I'm purely indie, do stuff myself. I have a studio, Shiba Dog Studios, which the first game went out in November. It's Tirelands. There's a link in the description if you want to check that out on Steam. And I do like freelance bits and contracting for other organizations / people who want to make games but don't necessarily have the tools or resources to do so. So yeah, I'm getting there. I'm getting there, but it's you know, it's a process, and certainly is not a lucrative industry. So by my definition, yes, I am a game developer. If you're judging it based on how much money I make from game developing, technically at this point I could say yes, I am, because things are going particularly well at the moment. But it's not sustainable. It's not sustainable. By the end of the year, if I wasn't to keep finding more contracts or, you know, signing a publisher deal or something, I would not be able to do game dev full time if I wanted to, you know. Cool, right, let's get this albedo texture plugged in on the shader graph. And actually, let's talk about the shader graph real quick, how this is working. So for the displacement, that's what we've got up the top here. All of this is pure displacement. All of the color stuff is down the bottom. We are taking a frame rate value. So this is like how many times I want the thing to jump around a second. You can't see the preview because it's below my head. Let's move it up here, shall we? We take that, multiply it by time, and then round it. So that it gives me like a stuttered motion. An alternative, which I've used down here for doing the offset on the paint texture, is to take the frame rate, multiply it by time, truncate that, and then divide it by the frame rate again. And I think that's actually a more accurate way of getting X amount of frames per second. So odds are I might just copy this and move it up top. But anyway, that's what we've got. We're then taking the position based on the view point. I'm almost more tempted to switch that back to world. Difference being it kind of changes the way that it stretches over the UVs. If we go from the view perspective, it's almost as if you're just plastering a flat texture over the viewport. Whereas if you go from world position, it still uses the object's UVs, but it kind of maps it based on where that object is in world space. So you end up with some texture stretching, basically, as compared to if you used view space. Anyway, so that's giving us our UVs. We're offsetting the UV by the frame rate value that we've just gotten here. Pass that into a gradient noise UV, which is what's giving us our noise here. Shade variation scale is what we're using to change the scale of that. And then we can take that output. I subtract 0.5 from it just to make sure that it gives me a value between negative 0.5 and positive 0.5 rather than 0 and 1, because I want, you know, the displacement to go sometimes to the left, sometimes to the right, not just between 0 and really far right. Multiply that by a displacement strength value, so that controls, obviously, you know, how big of a motion we get. And then we're taking that and adding it to the X value, or the red channel, of the world space position of the object. So like I say, I probably want to do this on Y as well, in which case we would take this out, get another add node on the B channel, plug in our multiply value here. Sorry, I mean the Z axis, not the Y axis. Y should stay the same. But yeah, we add that displacement value to the blue channel, the Z position. Take that, output it back into a combine, and then we can take that, transform it from world space to object space so that it's back relative to the object, and use that for our vertex position, and that's what gives us this nice little displacement. Cool. Onto the base color. Let's talk about this, because then we can factor in our albedo texture as well. So we have a base shade variation value. Again, this is the thing that we use to decide how much we want to vary the base albedo with our noise. Quite simple. I do a 1 minus on it because it gives us, we've got it as a slider, it goes between 0 and 1. The 1 minus means that we effectively get the opposite of that. So if it's set to 1, we end up using a value of 0. If it's set to 0, we use a value of 1. And the reason for that is that it means that if we've got it cranked all the way up to 1 on the slider value, when we go to do our remap here, which is remapping from a value between 0 and 1 to a value between whatever our variation value is and 1, we actually, if we're slid all the way up to 1, we get a value of 0 going into here. So we're going to end up remapping the value from this gradient noise between 0 and 1. We've got it slid all the way down to 0. We get a value of 1 in here. So we're remapping whatever this value is to be in the range 1 to 1. So basically it's always going to be 1, you know? So it means that we actually get more control over this band, or a more accurate control over the band, where when we increase the value of the shade variation, we are also we're actually increasing the influence, rather than if I plug this in directly to this node, we would be decreasing the influence as the base shade variation value went up. Bionicle, you made it. Welcome, welcome. I'm just walking through the shader that we've got for the paint asset, which, again, I'm planning potentially on putting this on the Patreon for people to just have, but at the same time, I'm walking through it now, so you could realistically steal it. It's up to you, I guess. Can't stop you. Sweet, so we take that, multiply our color variation by the base color, and that gives us our new varied base color. What we want to do is factor in this albedo texture. So I'm going to take this and put it through a sample texture 2D node. We'll use the UVs of the object because that's what I imagine our texture would be based on. I'm then going to take this, multiply by our base color so that we get some impact, and then we're going to take the output of that and plug it into our multiplication of the lighting over here. So if I save this asset now, we're going to see it looks really weird over here on our pot, and actually that looks kind of cool. Now our painted pot, if we put the shade intensity way up, you can see actually that's kind of cool. That is kind of cool. That is kind of cool. But we're getting like full shading of the object going on here. I wonder though, we're not getting like full blacks on there at full intensity. Like if I go here and set this to none. Ooh, oh no, it's because I've got two lights going on, isn't it? Yeah. And the smoothness value as well. The smoother we make it, the less like actual shadow we end up seeing. So if we make it not quite as smooth, maybe like 0.29-ish, and obviously again the shade intensity kind of affects how much we are shadowing. But if we have this all the way up to full, go ahead and stick maybe like a cement texture on there. That doesn't look nice. Tiles. We're kind of getting... Oh no, yeah, it's still shining through, isn't it? So we're going to want to figure out how to make it so that that's completely black rather than actually showing anything through. And that's going to be to do with our lighting shader code, which is always kind of scary. Either way, there is our shader. I'm going to put my my values kind of more or less back to where they were. Cool. And then we'll continue with a walkthrough of this shader graph. So that gives us our base color. Then we need to factor in the lighting. To do that, we have this painterly lighting custom node, which is what this HLSL is doing over here. So we'll jump onto that in a second. But it effectively takes in a bunch of parameters for, like I say, the smoothness of the strokes, the map that you want to use for what your paint stroke should look like, the specular color that you want on the object, the smoothness of the surface controlling how specular it is, effectively the shininess, and the shadow intensity, so how much you want the shadows to actually affect the object. We then take the output of that as a color, add it to the ambient color of the lighting, and then multiply that with our base color, and that gives us our final shade for what the object should look like. This funky stuff over here is just a way of me offsetting the paint texture. So we've got a sample texture 2D, which takes in the stroke texture parameter. I am doing pretty much the same as what was above. We're getting a change based on our frame rate. So every, 1/6 of a second, for example, we're going to offset by a 1/6, effectively. We're using view position again for the UV on this. Plug it into a tiling and offset, use that as the UVs for the texture, and then we can take the red channel because it's a black and white image, and I just need a float value or a half value, so take that, plonk it out into our stroke map, and our jobs are good. And do I think what I did for my game, which is making the mechanics first and working on the art style later, is the better option, or do I usually not do it like this? Oh, this is a good one because I'm terrible for it. I always pretty much, or historically, have always made art first because I'm a very visual person. So it's like when I come up with a game idea, I don't usually come up with a mechanic per se. I'll see like a picture or a set of colors, or I'll have an image in my head for what a game looks like, but not necessarily how it plays. Oftentimes, it's not the safest way to do things, because maybe it looks nice but it's really boring, or the mechanics don't make sense at all, it's terribly balanced, etc, etc. You can run into loads of issues with making art style first and then coming to find actually the idea for the game isn't there at all, or the idea for the game is just really bad. So generally speaking, when you're prototyping in the early stages, it's a lot smarter to build the mechanics first, at least in a rough sketchy form, so that you have that proof of concept, and then you can get people to play it. They can review it and tell you that it's hopefully good, or they can tell you it's really bad, and then you can scrap it and move on, or make adjustments if it's like halfway there but is missing this, that, or the other. On the flip side of that, when you're looking at marketing a game, especially with how people are nowadays, you know, with social media and everything, I feel so old saying that, but the people's attention spans are lower. You don't want to read about an idea that someone has. You want to see the idea. You don't want to spend like, you know, 20 minutes sat in a room with me telling you, oh yeah, you can put these plants in a pot and they'll grow, and you can like use bees to spread the pollen between different ones. It gets boring. But if I could show you a 10-minute GIF, a 10-second GIF of a bee flying to a flower and then flying to another flower, going to a third pot and a flower popping out that looks like a combo of those two, and it's in this nice painterly art style, people are going to click on that, they're going to share it, they're going to look at it and be like, whoa, that's exciting. So having a visual first approach to development is very beneficial from a marketing point of view. And, you know, a good approach actually that you can take if you've got more time or if you're working in a team is to actually do both at the same time. So have one subsection of your team or one person in your team working on prototyping the mechanics, and have the other person in the team or some other people in your team working on prototyping the visuals, which is the approach that we're taking with Circuit Assault, which is another game that we're working on at the moment, where I've got the responsibility of prototyping the visuals and kind of starting to build up a core code base there. And Felix, our other person who's working on Circuit Assault, has the responsibility of prototyping the mechanics and testing that the game is actually fun. And that's been really helpful because it means I can mess around making things look pretty, but we've already got like a built version of the game that's playable on itch.io, which is nice. So, you know, it's kind of, there's no right or wrong answer. It's safer to build mechanics first and get people playing and testing, and you can do that either in a game engine or even on paper. You know, if you're making a card game, for example, just make some cards and get people to play it. Or I was designing a roguelike a while back, which was based on Yahtzee. So I bought some dice. It was like £5 to buy a box of 100 dice. So I just bought them, made a key for what the different colors and values map to, and sat with Adele just like rolling dice and seeing if it made sense. And it was an interesting mechanic, but I didn't quite flesh it out enough. So yeah, it didn't come to fruition. But anyway, long-winded answer. Hopefully that answers the question somewhat. Just as a TLDR, you can do either. It's safer to prototype first and test the idea is fun, and then come up with a visual art style. Because it's also usually easier to fit an art style to a mechanic than it is to fit a mechanic to an art style. That rounds that off. Asking because you had your first Unity lesson last week on Friday, and so tomorrow's just wanted my thoughts. Yeah, nice. Also, big coincidence, first class project is making a card game. Nice. Card games are good because it's relatively straightforward data structures, I think. Same with something like Noughts and Crosses. If you want to make a multiplayer game, something simple like that is a good place to start. Right, let's talk about this custom node, shall we? Because I've been waffling on long enough. Let me pop open my painterly lighting subgraph. So here it is. This is the subgraph for handling the thing, because maybe I want to use the painterly lighting in a different shader, but I don't necessarily want it to have the jiggling or like, I don't know, use a texture. Maybe I want a lightweight version that just does the painterly lighting or something. So it's in a subgraph so that I can use it in multiple shaders. Literally everything that's in here is just taking in the usual parameters. We've got the position in world space, the normal vector and the view vector, all world space parameters, and then parameters for the other things that we need to pass in, as I said before. That's then pooping out a color, which we can use in whatever we want to do, and being handled by this painterly lighting custom function, which is referencing a file, custom lighting, and calling the method handle painterly lighting. So the way that looks in URP, at least, can't comment for HDRP or the built-in render pipeline because I don't use them. we have a void in here called handle painterly lighting underscore half. That's just a requirement of Unity. When you make a custom function, you have to suffix it with an underscore and then the precision. So because I'm returning a half value, or I'm working at half precision, I suffix it with underscore half. It then has a bunch of parameters for the input, which are all of those things that we said earlier. And then one parameter, which is an out parameter, meaning when we set it in this function, it outputs that value for us to use outside. And that's giving us back the color. So if we're in shader graph preview, we don't have access to any of the lights or anything, so we kind of have to fake it. The way I'm doing that is literally just setting the color to a float 3 that is white. So there's nothing else going on there. Because this is effectively, this isn't doing any albedo or anything, it's just doing color and shading based on lights. We're not concerned with the texture in here at all. So if we're not in the shader graph preview, i.e. we're actually in the engine doing stuff, we have a struct called surface params, which holds all of the data for our parameters. We set the specular color on that, set the normal view, basically set all of the data that we've just passed in, all of these parameters over here, store those in this struct, and then we can use that information for all of our future calculations. So we've got to check to see if we're using shadows. If we are, we can get some coordinate for the shadow position based on the clip position of the object. If we're not, we just set it to be transform world to shadow coords based on the position. We grab our main light first of all, and then call this calculate painterly for light method, which effectively does exactly that. It takes in a light, takes in our surface data, and then takes in a boolean for if it's the main light or not. So because we're doing the main light first, we pass in true, and that does all of our maths. We'll come to that in a second, just real quick afterwards, because I also want to support like point lights and things, because I would be nice to be able to add something like a fireplace or a lantern or torches or spotlights or whatever. So I want to be able to support additional lights for the lighting on these objects. If we have that keyword enabled on the shader, we get a count of all of the additional lights that we have in the scene, and then for each one of them, we grab that light using the get additional light function. These are all functions that are provided by Unity in the URP library by default. Pass in the value of I, pass in the position of our object, and then this is the distance attenuation, which is effectively how is that the distance? I'm pretty sure that's the distance attenuation. It's like how the light attenuates based on the distance away from the light that the object is, if that makes sense. But that gives us back another light object, and then we can add the calculation of the painterly light to our original color with that new parameter passed in. So we get this like additive combo of all of the lights that we've got. So the way that this actually works, I had originally written this all out just in shader graph instead of in a HLSL file, because it was just a little bit easier. I didn't have to delve into code, but you can't support additional lights in in shader graph, sorry. So moved over to using HLSL instead so that we could do this all mapped out nicely. First thing we do is calculate our attenuation. The way that we do this is using a smooth step function with the stroke map, where the lower band is the stroke map minus the stroke smoothness, and the upper band is the stroke map plus the stroke smoothness. So that gives us some like smoothing between 0 and 1 effectively. And then the value that we're using to decide where on that curve we sit is the light's distance attenuation multiplied by its shadow attenuation. So yeah, just basically getting the effect of the light based on how far away it is and how the shadows impact it, using that as the value that we do for our overall attenuation. Calculating our basic diffuse lighting, we are doing some relatively simple and common practice maths for this. We're getting the normal or the dot product of the normal of the surface and the direction of the light. We're then saturating that after we've added 0.2 to it. Saturation basically just clamps the value between 0 and 1, kinda. I think it's a little bit more complicated than that, but I am a pedant. I don't know shaders very well. This is that'll do. My understanding is that it stops it from going beyond 1 and below 0, so effectively a clamp. Computer shaders, they are forbidden knowledge. Bro, tell me about it. I did this and it still feels like forbidden knowledge, honestly. Anyways, so once we've got that dot product, sorry, that basically gives us how the lighting should be going across the surface. So we can use that again with a smooth step, factoring in our stroke map minus the smoothness, stroke map plus smoothness, and then we're using the dot product of the light and the normal vector as our parameter for where we sit on that curve, and that gives us our diffuse lighting. If we were to just stop there, not use a smooth step, but literally just use the normal product, we would get the default flat gradient that you get from white to black in a Unity standard shader. So that's what that does. The specular is a little bit more complex. We start off by getting a reflection vector for the light, which uses this reflect method. I'm not going to talk about how it works because honestly I don't know. My understanding is that it basically predicts, or it calculates what the reflection normal for the direction of the light based on the normal of a surface is going to be. So say we had a flat surface, the light comes in like this, it calculates what that vector for it coming out again would be. Following that, we're doing a similar kind of thing. We get the dot product of the view angle with the reflection angle, because yeah, specular is to do with where the view is. If you move around an object, the angle that the light bounces off into your eyes is going to differ, so you'll end up with a different specular calculation. I'm then getting a threshold, which is based on the stroke map plus the smoothness of the surface, not of the strokes, just the surface. And then yeah, we're literally setting it up to say that the surface specular color, we multiply it by the color of the light so that we factor in our lighting into the color of the specular, and then we smooth step it again. Same thing, specular threshold minus the smoothness, specular threshold plus the smoothness, using that dot product as our value for where we sit on the curve, and then multiplying it by the smoothness of the surface so that we get, you know, that spread of if it's a super clear dot or if it's smoothly blended over the whole thing. Quick pause. Do I have any tips on getting started for writing shaders? Yes, actually, there are some fantastic YouTubers out there who are really, really good with their documentation, not documentation, but tutorials on basics. The main one I'd recommend if you're using Unity is Daniel Ehlert. I think, to be fair, most of the principles of it all carry over between Unity, Unreal, Godot. It's all maths, basically. It might just be some like differences in names, but most of the common functions will exist because they're all using either DirectX 11 or DirectX 13, whatever it is that we're on now, or OpenGL under the hood. 9 times out of 10. There may be exceptions, but most of the major game engines, Godot, Unity, Unreal, all use those. So following one of their tutorials, Daniel Ehlert's got some really good entry-level ones that look at all of the shader graph functions. And the reason that's okay is because the functions, they all map to an actual shader function. So like this line of code here, the smooth step for surface.stroke_map minus surface smoothness, blah, 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 all of that lines up with something else that I might have in here, for example. So this is my skybox shader, very simple. It's literally just creating a gradient from one color at the bottom to another color at the top. If we wanted to write this in shader code, and I tell you what, let me actually just pull my IDE over here real quick so we can look at these side by side. So if we imagine we had a void get skybox, we can take in a position, so that's going to be a float 3 position. And we'll also take in a float 3 bottom color and a float 3 top color, like so. This is effectively the same as the parameters that we're getting here. If we wanted to normalize, we're going to say something like float 3 normal position equals normalized, or normalized, sorry, position. So that's our first step. If we then wanted to split, there is going to be a split function. I've probably chosen a terrible example because I don't actually know what the split the parameters for split are, but you know, you can hop on here and say HLSL split function, and likely track something down in the docs somewhere. I mean, here's the documentation about the split node. I wonder if it's got some link back to what the HLSL looks like. You've sent me off on a tangent, but I want to find it now to prove a point. Unity shader code split function. In fact, I don't think we even need to do a split. It would be the same as if we went on here and said, so we want to get the Y value. We probably want to say float T, for example, equals, and it's going to be remap normal position dot X, and I need to be thinking what I'm doing. So that's the value that we want to remap, not X, Y. And this is definitely where I would need to Google something. HLSL remap function. There we go. So it's called inverse lerp, origin from, origin to, value, and then we return a lerp. So we kind of have to do some stuff ourselves, but most of the functions are all going to be relatively straightforward mappings to some smaller block of code or just a single method that already exists, like normalize or smooth step. Lots of these things are already there, and I wouldn't be surprised, to be fair, if remap does already exist in URP as a function that you could grab, although judging by this, like scanning through this, it doesn't look like it does. But yeah, my advice would be similar to kind of learning anything. Go watch some tutorials for a little while and then come up with things that you want to make that sit in a similar realm to those tutorials, so that you can start experimenting, and kind of really don't just idly follow a tutorial and recreate without thinking about it. Try to actually think about what people are doing, why they're doing it. Obviously ask questions in comments or with other people, join some communities, things like that. But yeah, just experiment. It's like any other programming language. The approach is all based around problem solving. It's just a case of learning the tools and being able to get further along with it as you go. Hopefully that was kind of helpful. I understand I rambled a little bit there. Anyway, diving back into talking about this shader here. We've done the specular, so the last thing is actually figuring out our color. So what I wanted to do, because there's a problem that I'm running into here, which is to do with the way that additional lights behave, and this is another reason why I kind of want to separate some things out so that we can do more of this in shader graph rather than just in a HLSL file. And that is that for our shading map, by default, we want it to just be the diffuse value multiplied by the attenuation. I've then added an if to say if it's the main light, we're going to apply our surface shading intensity. So this is a similar kind of approach to what I was saying over in where is it? Yeah, we save over in here where we're doing our 1- on the base shade version. The higher this value is, the more I want to apply. So it's a similar kind of thing here. The higher the value of shadow intensity is, the more I want to apply this shading map. So we do a 1- of the surface.shadow intensity and add it to the shading map, which ends up getting us that difference in effectively the base color, the diffuse times the attenuation, and the full shadow. Cool. So then the final step is to just calculate our color, which is the color of the light multiplied by our shading map, again saturated, so it sits between 0 and 1, plus our specular, so we get like some nice highlights in the right color up at the top point. Oh, this is my problem actually. I can just do this better. Let's change that. So we want to apply the specular after we've multiplied. So we're actually going to do this all as one, and I think I probably don't need brackets here. And then we add the specular afterwards. So if we head back into Unity now, let's go ahead and take a look at our pot. Yeah, there we go. We now have, that's the stroke smoothness. That's not what I want to change. I want to change the surface smoothness. Wait, no, they're still brown. Why are they still brown? My guy. What we want to be seeing is that the specular is pure white. If we change it to red, I mean, it's pure red there. That is pure white, actually, isn't it? That's not brown. I might just be tripping. Does Unity automatically translate HLSL into a graph for you? Kinda. So there's a thing in shader graph which is custom functions. So you can go ahead and create a custom function under utility as a node. And then this custom function, you can either pass in, let me move this up here so it's more visible on the screen. Yeah, there we go. You can either pass in a file, which is what we're doing for the painterly lighting, or you can just have a string and write the body of the function straight in. Doing a file is usually better because, you know, source code management and all that jazz. But also being able potentially to have multiple functions in one shader file and then just calling the ones that you need. It's much more handy to kind of work like that. If you're following the right syntax for it, it will just, yeah, it'll pick up this function and do whatever you need to do in it. There are a lot of cases where you'll probably need to check for if it's a preview in shader graph or not, or you'll end up with errors being thrown. But yeah, that's how you kind of interface between the two. I can't comment too much on writing like pure HLSL shaders, because like I say, this is kind of my first experience dabbling with shaders. I only really started learning them like 3 weeks ago when I was doing visual development for Circuit Assault and messing around with custom post-processing effects. But yeah, that's how that works. Yeah, exactly. You're welcome. Right, so I may be being stupid, but I genuinely can't tell if that looks white or if it's brown. And I think one way we can check is if we crank, yeah, there we go. So you see it's still getting that applied. And actually, you know, I can tell you exactly the reason for it. The reason that we're still getting that is if we look in our Painterly shader, we're getting all of this lighting as we were, factoring in the color of the light, adding in the specular blah blah blah, returning the color, that's all fine. But then we're taking that color out, multiplying it by the ambient light color, and then multiplying the whole thing by our color for our object. And that's not what we want to do. We want to have the specular be added after the fact. So get the base color first, then multiply it by the lighting, then by the ambient, and then by the specular. So there's there's an option that we have for this, which is to, you know, take our specular and just out it as a separate value. And we don't apply the specular up here, we just do it in a separate place. And I'm kind of tempted, not gonna lie. We don't need to use anything else in here. So yeah, let's do that. I'm gonna make a new function, float 3, sorry. Yeah, float 3, calculate specular for light. And this is going to take in some similar parameters. We're going to have a light, we're going to have a surface, params, surface. And we're just going to take all of this out of here and then return our specular value rather than adding it on at this point. Following that, let's add an additional output, specular. And then we can say specular equals calculate specular for light, pass in the light, pass in the surface, and do the same thing again down here. We're going to say specular plus equals calculate specular for light, light, surface, like so. Hit save, go back into Unity, and it's going to scream at us because we need to go back into our custom node and update it to actually support these outputs. So we're going to add a new output of type vector3, which maps to our float3, and we're going to call this specular. We'll also add an output to our graph here, specular vector3. Hey, what you doing? Vector3, I said. There we go. Plug that in there. Cool. We still have an error. What is this error? Wait a minute. I might have messed something up here. No matching parameter. Oh no. Okay, so something wacky is going on with our parameters for this actual method. Which it shouldn't be. 1, 2, 3, 4, 5, 6, 7, 8. 8 inputs. 1, 2. Wait. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, 8 inputs, 2 outputs. 8 inputs, 2 outputs. That lines up. That's fine. Here's where my shader programming is going to start coming undone. No matching 9 parameter function. Have I accidentally got 9 inputs in here or something? No, I've only got 8. Yeah, passing in 4 vector 3s, 4 floats, outputting 1 output parameter specular not completely initialized. Ah, there we go. I need to set it to a value in here. So let's go ahead and say specular equals, and what do we want the default for this value to be? I guess we could just say float3, maybe like 0.2, 0.2, 0.2. There we go. I can ignore that. That's not a problem. Oh, I lied. Painterly lighting. Maybe we just have to reload this node. Let's do it. No, it's still complaining. Oh, wait. It's because I haven't actually saved. There we go. Save that one. Save my subgraph. Boom, we're back. So now we've got the specular. So we can see now on the preview, if I change my surface smoothness, we're not actually getting any effect. What we should be able to do, I think, is take this output value, the multiplier that's multiplying the lighting by the color, and add it to the specular. Save that up. Boom, we have white specular back. Fantastic. So we can make that like super point bright, or we can make it really not. Which is great. Cool. That's handy. That's very handy. I mean, I think I might leave the shader stuff there for that. And you know, I wanna put this through a redirect instead of sending it straight up there because it's messy. Oh, what's the under utility, not preview? Or maybe it is a preview. Maybe I could just take a preview, shrink it. That'll do. Output to there. So that we've got just like a little bit of help in there, instead of it being crazy. Cool. Great way to spend an hour. This is perfect though, so yeah, if I hit play now, let's take a look at all of this. Actually in the engine. There we go, look, our pot now has white specular. And I mean, like I was saying before, the best part about this is completely reactive to, you know, everything that we want to do. So if we want it to be like nighttime, let's say, make it kind of dark, and we can add in like a point light, point light. So this is the problem that I was talking about that we've got going on here. I've made this point light. Everything that it touches instantly gains the color. Because we're kind of doing these because of the way that we're doing something. I haven't quite figured out what the fix for this will be, but it does make it very difficult for us to get the effect that we want. But yeah, we can imagine this is like a torch or something. Raise it up a little bit. And yeah, we get complete nice shading over here, which like I really like the way that the effect looks, and it's fully inclusive of shadows. I just at some point will need to figure out this lighting issue, because like I say, if we were to go into the scene view and just move this light so that it's not overlapping with the pot anymore, you see the color just kind of pops away. It's not just applying the color to the area that we're sat on, or to the area that it's covering. And it's something to do with our shadow map. Which makes me wonder, do we do the shadow map, or do we do our additional lights first? And then the main light afterwards, because then we can just use a shadow map for the main light to calculate our stuff. I don't know. It's something we'll come back to, but like it looks really cool. It looks really cool. If I do say so myself, I'm very happy with how it's all coming together, and I think it should work with emissive materials. Cool. So, what I would like to do now is actually write some code we are going to make use of a grid for handling the dragging and dropping of our objects. And this is kind of what I was waffling about in the description for this video, is, you know, being happy to kind of switch about what your plans are. Because obviously at the moment, you know, like I was saying, we're just free-handing everything. We can drag and drop anything wherever we like, including off the side of the map, in which case it will just fall forever. We don't want to allow that. We want to have a grid that has positions, locks things into those positions, but also has bounds, so we're not allowed to put things outside of those positions. And I think our Unity grid here, so yeah, prerequisite, I've added a grid to the scene. This is going to be our grid manager. This is Unity's proprietary grid component. Oh, I think I've also just noticed that my chat has stopped working, or maybe not. It looks like it has. It looks like it has on screen. I don't know when that happened. Apologies. Yeah, this is Unity's proprietary grid component. It gives us a load of functions for like taking a grid, and like setting sizes of things, giving ourselves gaps between stuff. So we could have a gap of like 0.1 on X and Z between everything. Yep, cool. So that will now give us a gap across ways and width ways. It's really weird to kind of use the grid in world space because it's designed for 2D, but it does work with 3D. So yeah, it'll have a gap of 0.1 in either direction, but then we can use that to convert between positions on the grid to positions on world space, have things, you know, jump to those positions. So what we would like to do is actually, you know, if I've said this, I think the ground is 10 by 10. So if we imagine we've got a 10 by 10 space in which we want the player to be able to work, we can grab the position of the mouse, use that position to then get a position on the grid. And if the position on the grid isn't within some bounds that we've set, we can, you know, ignore the position completely. So that's what we're going to do. I don't think I have a grid manager anymore because I deleted it after the first stream, which we did on the 29th of March. So let's go ahead and actually create a grid manager. I'm going to go straight ahead and stick the grid manager onto my grid manager game object, and then we can pop it open in VS Code and start writing some stuff. Also, just so everyone knows, this error that I've got here is something to do with my custom editor that I made and Odin. There is a workaround for it. I just haven't gotten around to putting it in place yet, but it's to do with the way that I'm saving and loading prefabs, I believe. So don't worry about it. Don't worry about it. It's a me issue. Cool. I'm going to delete everything from in here for the time being, and we're going to jump straight into writing some code. This is nice. It's also kind of weird, like working in VS Code for Unity. I'm so used to working in Visual Studio and only using VS Code for like JavaScript and Python. So yeah, very odd. Right. We want a serialized field, private grid, and this is going to be our grid. I want this to be a singleton. So I'm going to put my singleton stuff all up at the top. It's not going to be a persistent singleton. It's just going to be a singleton. So we don't need to do anything special with like not destroying on load. Have a private static grid manager s_instance. And then a public static grid manager instance, which returns our s_instance. Then we'll have our awake method. In here, we will say if instance is not equal to null, destroy. this game object and return. Whoops. Otherwise, instance equals this. And then we can do whatever other stuff we need to do in here. I think what I would like to do is also have a public grid, which is just returns, gives us a getter for this grid, so we can't set it, but we can still access values on it. Or maybe we actually have methods inside here instead. So we'll have like a public void check valid position, which takes in a vector 3 position to check, and this should actually probably be a bool that we're returning here. Nice. For now, let's just return true. What we're actually going to do is query our grid based on our parameters. So let's go ahead, have a serialized field, private vector 2 int. Yep, we want a vector 2 int, and this is going to be our, not vector 2 int, sorry, vector 3 int, and this is going to be our grid bounds. Nice and easy. And effectively what we're going to do is take the position to check that position on the grid, and then see if that position is inside the grid bounds. And if it's not, we obviously return false. If it is, we return true. Choking. How do we do that? So we can, oh, this is going to be handy actually. We can use like tweens and everything for actually handling all of our positioning, instead of using rigid bodies, which is fantastic. So to get, to check if this is a valid position, first things first, I want to make sure that we're looking at the position based on, you know, the grid bounds around 0, 0 in world space, not like that, you know, you'll see what I mean. So we're going to, I basically want it to be on the X and Y, the center point is 0, and then going, so yeah, we can go half of the width that way, half of the width that way, and then the full height all the way up, but nothing down, so, if that makes sense. So we are going to say var position on grid equals grid dot get cell center world, pass in position to check. Oh, it wants a vector 3 int. Oh, wait, okay. Start again. We want to get a vector 3 int tile at position equals, and that's going to be equal to our grid dot get tile, or tile what have we got here? I would like a world to cell, local to cell, world to cell, there we go. Position to check. Oh my gosh, can't type. K, there we go. So that's going to give us the cell position for this world position that we want to check. Yeah, and then we want to, in fact, I don't think we even need to do this. We want to take that position and offset it by half of the grid bounds. Or at least offset the X and Z, or the X and Y position. No, the X and Z position. Yeah, offset the X and Z position. So we're going to do... Is that what I want to do? Is that what I want to do? No, yeah, that is what I want to do. That is what I want to do. So I want to say if tile at position dot position. Oh no, that is the let's rename this. Right, I want to try refactoring. Ooh, I can. That's not how I rename it though. I rename with F2. Function F2. There we go. And this is going to be tile position. Position. There we go. If tile position, or maybe, okay, right. Last time I jump around, I swear. Offset tile position. Equals new vector 3 int tile position dot x plus grid bounds dot x over 2 tile position dot y and tile position dot z plus grid bounds dot z over 2. So that should give us our tiles position converted to our grid bound space. So then we can say if tile position, oh well, yeah, we want to do a load of checks basically. So if tile position dot x is greater than tile bounds, or grid bounds, sorry, dot x, or tile position dot x is less than 0. Oh wait, no, I'm being so stupid. I can just do grid bounds dot x and we can have it be, oh, yeah, we don't even need to do any conversions. Amazing. So yeah, if we've got that, or, and then we go through, we do it for y, we do it for z, then we return false because it sits outside the bounds, otherwise we return true. So let's go ahead and change that to y, 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 and y, 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 like that. And then just to see if this is working, just to test some things out, let's maybe give ourselves a control on the camera controller, which this is a terrible way to do things, but I'm feeling lazy. Because I've got access to, oh no, maybe I won't bother. Maybe I will do something somewhat proper on my grabbable object. Let's say when we drag it, when we update the drag position, we're grabbing a position on the XY plane. So let's just say if we hit the thing, we'll do a grid manager dot instance dot check valid position, and we'll use our ground position, which of course we haven't got yet. There we go. And we'll log that out. Is valid grid position There we go. So we can actually see. Wait, no, I've just thought we can't actually do it like that. Oh wait, yeah, we can. Sort of. One thing I'll need to change if I do it like this. So we want to be able to go positive x, negative y, positive x, positive y, negative y, and then the z. Or the y in this case, we just want to check if it's greater than grid bounds y times 2. Because we want this to be the half bounds. So I'm actually going to go ahead and rename this grid half bounds like that, so that it's a little bit more accurate. I think realistically what would make more sense is if we set 2 vectors. We had a min bounds and a max bounds. We'll do that in a second. So it's going to be 5, 5, and 5. That gives us a 10 by 10 by 10 grid. We're going to set the gap back to 0 on all of them so that we've got everything touching. And then I'm going to hit play. And we're going to see if this works. Oop. Bruh. Whoop. Let's do this, and then we can grab a reference to it. Grid equals get component grid. Do that in the awake. Cool. So what we should see is that if we drag our object anywhere over this square, because it's in a 10 by 10 grid with, you know, positive 5 this way, negative 5 that way, we should see true. If we go outside the square, we should see false. Let's find out. Let's find out. Oh, look at that. We're getting all false everywhere. All false everywhere. So let's let's do some debugging, shall we? Let's figure out why that is. So in our grid manager, we're getting our tile position. Let's debug.log. Some stuff out. World position, or better yet, let's call it check position. It's going to be position to check, and tile position is going to be our tile position. Cool. Great. So that should be fine. Everything is good there. Look at that. We're getting valid things. It's 4-4. Can even go out to 5-5, which is actually too far. But that is indeed giving us the positions of everything that we want. -5, -5. Oh, I think I know what it is. It's because Actually, no, I'm lying. I don't know what it is. Yes, I do. That needs to be negative. That needs to be negative. I was checking to see if it was either bigger than or less than the same number, which means obviously it's always going to be false. Now we should be getting true thrown back. Yeah, cool. There we go. That's true. And if we bring it out here, there's our false. Amazing, 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 amazing. So, using that now, we can actually probably change this to be get valid grid position, and we output. Yeah, let's do that. Let's do that. Try get valid grid position, and then we'll out out vector 3 int tile center position, or tile, yeah, position tile center, position tile center. Yeah, we can give it back as a vector 3 because we can pass between that. So we can set it to be the position to check by default. And then, oh, actually, no, we don't even need to do that. We can just go here and say position tile center equals grid dot get cell center world tile position. Fantastic. And then back over in our grabbable object, we're not going to do this. We are instead going to say if grid manager dot instance dot try get valid grid position. I'm going to pass in the ground position, and we are going to out target drag position. Or maybe we will out into a variable, just out var grid tile position. And we'll say if we don't do that, we'll return. If we do that, we're going to say our target position or our drag offset is equal to not the ground position, but instead the grid tile position. And we use grid tile position here as well. We probably want to do a similar thing here. So for our physics box cast, the center is going to be the grid center position. So if there's something at our grid tile position, then we're going to increase the height of our drag point to be that thing that we hit, dot y. And then we have some offset position. So, okay, we should now have grid, basically we should have grid snapping now. So we're doing a check to see if we are hitting the grid, we're hitting the grid, then we do the thing. Yeah. So this won't work for when we drop, it'll just be when we're dragging, we'll have it in the right position, but it should now snap to the grid because we're saying if we're not at a valid grid position, we're not going to allow it to drag any further. Otherwise, if we are, use that grid position as the target position for our movement. Bruh, my cat. Oh, can you come? Being a menace as always. Right, let's hit play and see what we get. Also, there's a new microphone that's been released. There we go, yeah, look at that. We are getting grid snapping. And I can let go and it still falls. I think probably it's snapping way too high. But yeah, it means we can't drag stuff outside. Right, we're gonna have to change this around because it stops moving when we're not at a valid position. It will just stop moving. I caught it. Okay, cool. That lets us drop there. Now we can drop stuff perfectly on top of each other, and we almost get this nice stack. The only thing that we won't have is that we're not going to have like stacking on objects, so we'll figure that out probably on the next stream at this point. But that's pretty nice. Maybe we can have a boolean as well for if we want to snap things to the grid, or if we want to allow free movement, because the water is less satisfying, I think, if it snaps to the grid. Or maybe it's okay, especially if you're moving around quick, actually. Yeah, you don't really notice the difference. Maybe we smooth things a little slower as well. That's fine. Okay, that's good. So we've got some snapping now on the grid. That's something. Rather than doing this, what did I just do? Rather than doing that and returning, we instead want to just wrap all of our code here into this if statement. Make sure we update our drag position in there as well. So that way we're still always doing the movement. Yeah, it's a little bit, yeah, it won't update the position unless it's a valid position. I'm going to up the drag follow time to 0.25 because we want it to tween a little bit slower now between the points. And this is like the first step in the process to being able to get rid of our rigid bodies completely, which ideally I would like to do because it will massively improve performance. Okay, that's maybe a bit too slow. Maybe a bit too slow. We also want to make sure that we can't go outside the maximum bounds, so we'll have to do a check to see if it's within the position -1. Is he actually going on to... Yeah, he's perfect in the middle. Are you perfect in the middle? Yeah, perfect in the middle. And perfect. Almost perfect in the middle. You have to wait for it to get there, and then it will be perfect in the middle. So that's something else that we want to do, is make sure that it gets there first, before the person has the chance to let go. Cool. Let's maybe go 1.5 on the drag. Sick. So what I think we probably want to do then is, rather than having yeah, there's gonna be some stuff to untangle in here. I am gonna just zoom out a little bit because the text is quite big on screen. It's kind of hard for me to read, I'm not gonna lie. What have we got? What time are we at? 5 o'clock. Okay, got about 30 minutes or so before I'll have to wrap up. So let's see if we can try and get this whole grid system done between now and then. I am getting spammed with emails. Hold on a minute. Yeah, I can deal with that later. Right. So, what are we looking at? When we are doing our when we're doing our dragging, we don't want to use the rigid body anymore. We instead want to have like a grid position, or like something along the lines of a standard grid position, which is going to be our target position, and then we can offset that based on whatever we drop the thing on top of. Yeah, I think that makes a lot of sense. It should make a lot of sense. So I'm going to just delete that and I'm going to remove the requirement for a rigid body. We're still going to keep our collider because we probably want to use that at some point, but now we can go through, we can remove that from there, remove this from here, remove that from there. Good. So I think probably what this means we can do is actually be doing this every frame, updating our transform position. Like so. And rather than doing the addition of the ground offset here, we can do it in here. So we can say something like var target position equals is dragging question mark target drag position plus that. Otherwise it's just the target drag position. And then I'm going to rename the target drag position to grid position. And then we'll use target position. Calm down. In here. Cool. Am I going to have loads of errors now? It's always the question. I've just changed something. Is it going to break everything? No. Let's go. I'm going to go ahead and just remove this debug log from here because we don't need it anymore. We'll do the same in the grabbable object. I don't need to know. Oh, we already did that. Cool. So now we're always going to set our grid position to something. This is probably something that I want to consider actually. So what we want to happen is, if we're dragging it, we want to update our, yeah, okay, cool. Let's let's have an additional parameter. So we'll have a grid position, and then we'll have a private vector 3 drag position. And yeah, then here, rather than doing all of this, we can say if we're dragging, we use the drag position. Otherwise, we use the grid position. That way, when we're over here, we can say grid position equals our grid tile position. Probably also factoring in our thing. Although what I would like to do is do a raycast downwards, or perhaps we do that on the outset. Yeah, we'll do that on the offset to get the when we drop to get the Z position. I'm fully waffling. So yeah. We're gonna say, whoops. Yeah, no, grid position equals grid tile position, like that. And then that's fine. We'll say our drag position is going to equal our grid position plus our drag offset, which is going to equal vector 3 dot up multiplied by our ground drag offset. So then over here we'll actually say drag offset dot y plus equals that. Then it's going to be grid position plus drag offset. Sweet. We should now have no issues. We should now have no issues, yeah. What we are going to do is just do a check in our on drop to check where it should end up. So in the end drag, we'll do, yeah, box cast downwards. So if we hit something, we can say grid position dot y equals hit dot point dot y, and then also invoke our event as we were doing before. And that way we can also implement stuff like stacking, where maybe we want to be able to move move things that we have sat on top of us based on some vector. And maybe we'll even have time to implement that, actually. We'll see. Yo, everything's going to 0. Stop it. Oh god. This feels like a problem. Feels like a problem. I guess in the first instance, let's do just on start. Let's do grid position equals, or no, we'll just do grid manager dot instance dot try get valid grid position, and we're going to pass in transform dot position out grid position. So that should then put everything at the start to its nearest grid position, I think. That's not quite right. I think it's probably because they have rigid bodies on them, isn't it? Let me go ahead and bin those off real quick. The seeds are going to go crazy. Whoops, I didn't mean to hit reset, I meant to hit remove. Same with the water drop, we want to remove the rigid body from that. Cool. Now hopefully things won't ping about the place a whole bunch. Okay. Okay, so stacking is kind of working. The click and drag just isn't working. But look at that, we got seeds stacking on top of each other. Sort of. We'll need to offset the position of stacked things by their own size. And then I need to work out why. Am I not setting is dragging to true? I think that's exactly what's happened. I need to go here and say is dragging equals true. And then when we stop dragging, is dragging equals false. You know, maybe we do that first. Oh no, we'll do it last because we want to make sure we get our positions right. Wunderbar. And then for the position that we're offsetting to, we want it to be hit.point.y plus vector3.up multiplied by drag collider.bounds.y extents.y. Oh, what am I talking about? No, I can just add the two together. It's two integers. Duh. I think that should do it. And then it's going to be a similar story up here. We also want to make sure that we offset the drag position plus drag collider.bounds.extents.y. Make sure that we're floating above where we want to be dragging and dropping. There's definitely more tweaks that I'm going to need to make to this after the fact for it to work exactly how I want it to. Okay, there we go. There's some dragging going on. Nice, okay. We're kind of working. Things aren't settling right down on the floor, it seems. But we do definitely have... There we go. We've got some stacking going on. Look at that. That's pretty nifty. I wonder if I can just go onto my ground material. Graphics, materials, ground. Let's give it that that tile texture, floor tiles. They are way too big. I need like prototype textures or something. Can you imagine a small tile, a small crate even? Yeah, maybe I won't bother. I think I'm probably all right. I can set up a grid a little later on, but yeah, we've got some action going on. I just need to figure out the how we get these to actually sit on the floor, and I imagine it's probably a case of just dividing this by 2. And then the same over here over 2. And I think we actually probably want to do the same kind of thing here, don't we? When we start the game, we can say grid position plus equals that grid position dot y, sorry, plus equals that. No, we're still hovering above the floor. Why are they hovering above the floor? That one's not. Oh, it kind of is. Oh wait, no. I think it is because with my my bucket and my, it's just the seeds because they haven't got that origin point at the bottom. Yeah, we'll just have to sort this. So because these have their origins at the base of the object, we don't need to offset them, but the seeds, they need offsetting. Cool, no worries. No worries at all. What am I doing? What am I doing? Shift, delete. Go ahead and delete that. Go ahead and delete that. And eventually it's going to make sense to extract a lot of this logic out into their own methods that we can call from different places. Because we definitely want to be a little bit more dynamic about things than we are at the moment. There we go. Yes. Put my thing on top of my bucket, and I can't drop it outside the map. Oh yeah, we still need to fix that out of bounds thing, because it's a bit weird. That's pretty sick. We can go ahead and stack things. One thing that we won't be able to do anymore is put seeds. Oh, no way, that still works. That is a fluke. That is fully a fluke. We shouldn't still be able to put seeds in things. What does my water body, my water want? Oh, it wants to have a force added to it. So yeah, we'll use some tweening on that eventually. It'll be the same for the flower as well. Gonna need a rigid body and the seeds. Yeah, okay. So we'll have some more refactoring that we need to do for sure. But that's cool. That's good progress. That's good progress. Let's go and fix that bounds thing real quick. Creating the bounds -1. Creating the bounds -1. Oh, or I suppose rather than doing that, let's do greater than or equal to. that's a little bit nicer. And yeah, we'll definitely come back and refactor that to actually define some proper bounds. We could even do it with a collider or with some bounds. I don't know if bounds are serializable in the inspector. Cool, yeah, we can't drag stuff off the map now. That Y position is doing weird things still though, in terms of where we should be dropping stuff. Like that definitely should not be a thing. Oh, where's that seed just gone? Oh, I put it on the wrong tile anyway. I want to put it on top of this bucket, but I don't think it's gonna go. Yeah, it's ended up on top of there. That's another thing as well. We do need to have stacking in place if we're going to do this. Okay, cool. All right, well, I am running out of time to get into doing anything more, so I'm going to call it on the stream for that one. But thank you very much, everyone, for watching. If you enjoyed, please leave a like and subscribe to the channel to get notified when we do more things. If you want to get more involved with the community, there's a Discord server down in the description. If you want to support the channel, support me as a creator and the studio, you can subscribe to the Patreon, where you'll be able to get things like the Skybox shader, the Painterly shader, our Shiba core utils, and all the rest. If you're not a developer or you don't want to be paying, you know, a reasonable amount every month, then you can also support on Buy Me a Coffee, link over there or in the description if you're that way inclined. And with that, thank you very much for watching. I will see you in the next one. Cheers.